now I will share with you inside design. Okay, go to simulation environment. Okay, inside the simulation environment, you will have this option. Okay, you can have all these options to do the simulation. Okay, let's say I'm going to use the static stress, and then I just click create study, and it will come out with the static stress environment. Okay, so what we need to do is we need to have the material here and the constraint here and also the load here to put it inside our study. Okay, so the first is I'm going to use the study material. Okay, let's say I'm going to edit the material. Now I'm using steel. Okay, let's say I'm not going to use steel. I'm trying to use maybe iron cast, for example. Okay, then I just hit OK here. Now my study material will be iron cast. Alright. So inside the iron cast material, it's already included with the properties that needed inside simulation environment. Okay, next is after putting the material, I will make the constraint. Constraint is where you want your part to stop, or maybe you want to fix the location of your part. Alright, so using constraint, it have the several function here. Alright, the type here you can choose between fixed, pin, frictionless, or prescribed displacement. Okay, let's say I'm using fixed. Fixed means your location will not move into X, Y, and Z direction, and also the rotation of X, Y, and Z. So it will make the your geometry will fix at the location itself. So let's say I'm going to fix here at the bottom here the location for stopping or to handle the load from upstairs. Okay, and then now I'm going to put the load. Okay, inside load it have the several function on your load. You have structural load, linear global load, angular, toggle gravity, which means you want to add gravity inside and point. Okay, let's say here I'm going to use structural load, and then I'm just selecting the face up here. Okay, 3 face here for the load to have. Okay, and for the magnitude, I'm going to make it maybe 10,000 Newton, which means alright. Then here, if you see the contact here, contact means you want your assembly to undergo the your assembly to undergo the simulation also. Then you can use the contact. But mine's one your element order, you can change between parabolic or linear. Okay, let's say for linear, basically we have the structural shape with the same geometry, so we can use the linear one. But for the parabolic, you can see your shape will become a solid element. Alright, so let's say I'm just make it the default without changing anything inside here. Alright, I'm just hitting OK. Now here under the soft option here, okay, inside the soft option here, you can see the pre-check. Right, the pre-check you can click and it will inform you the study setup has all the information required. Means that you can directly make the calculation. Alright, and then inside the soft here, okay, is where you do the simulation process. Okay, inside the soft dialog box here, okay, you have the on cloud and locally. Okay, on cloud, basically you will need the cloud credit. So here I have about 100, and for this simulation it required 5. So that means it will deduct 5 cloud credit from 100 and will become 95. Or else, if your computer is good enough, okay, you can do it locally. Okay, which means the calculation is using your processor to do the calculation. Okay, let's say I'm using the local and I click on soft. Okay, then it will running the calculation inside my computer without using the cloud credit. Okay, now we have the result. Okay, so inside the result you can see this is what happened when 1,000 kilo load is forced into this beam. Okay, so this is the safety factor 1. Okay, you can check the stress, okay, which is covered by von Mises stress, first principle, third principle, normal and shear. And then for the displacement also you have the total, which means included X, Y and Z, or you can change between only you want to see the Z, Y and X. Okay, reaction force also you can set the for the unit itself, Newton, dyne, pound force, ounce force and ton force. And the last one you can have the strain value, okay, which is got equivalent, first principle, third principle, normal and shear. Okay, this result you can customize here. You can see when I'm dragging this, okay, you can see the visualize inside your design window here. Okay, so actually for this load it's been scaled or adjusted to show us the deformation. If you select the actual one, and you can see this is what happened. The actual shape means, let's check the displacement. Okay, here is mean 0.02 mm. So that's mean this displacement is only a little bit of your original location. So it doesn't mean this part will, this part can handle the load itself. Okay, so how about if I want to generate a new simulation? Let's say I'm going to use this profile, okay, this geometry, and I want to create another simulation. You can just right click here, new simulation study. Alright, and then you can select any type of this egg simulation that you want to use. Okay, let's say I want to check the model frequency. Okay, now I'm creating the study. I didn't do anything towards this. I didn't put the material, I didn't put the constant, I didn't put the load. But when I check the study, it has all the information required. Means it's remember your old load and material that you set earlier. So let's just click the soft here, and again I'm using the local, and I click on soft. So now I have the second calculation towards model frequency. Okay, so let's wait a while until the calculation complete. Alright, so here is the model displacement. Okay, total model displacement. You can have here mode is, if you want to see the frequency, you can select in here. Let's say under 411 frequency, so it will happen like this. Okay, inside result here you can also play the animation to see the how your structure will move under the natural frequency situation. Alright, okay, so under the result tools here, okay, legend option is these things. Okay, these things, the probe here is the legend. So let's say the size, now the size is small. If you want to make it bigger, you can check the normal one. Now it will become more bigger and large. So this one is the biggest one. Okay, the color, for the color transition, you can have smooth one or bend one. Bend, it will make a little bit drastic color. Okay, so if you pick the smooth one, it will blend your color inside. Okay, how about the reports? Okay, you can click here and to generate your report. Okay, so let's say which study you want to add, just tick the study that you want to see the report. Okay, and then this is the option that you want to add inside. If you don't want, you just uncheck it, so it will not included inside your report. If you want it, you just add everything like this. Okay, so you can preview first before you actually save the report. Okay, here I'm clicking on preview. Okay, you will have a report like this. Okay, so you will have the math, solid, type solid, notes, element. Okay, the fixed one, location fixed, the force. Okay, and then the entities, the selection of entities, which mean the load one, and then the result summary. Okay, we have the safety factors, minimum and maximum for the stress, war misses, first principle, principle, normal, shear, and for displacement, everything in a table here. Alright, and for the safety factors, so that this part is good enough for us to do the to go to the next step or going for mass production. And then for the warm misses stress, okay, you can see here, and the location depends on the color. Okay, first principle, third principle, and the displacement of your product. Okay, so do you have any question for me? Okay, if you don't have, now you can submit letter to my email, which is yusri@acadsystems.com. Okay, so that's it for today. Thanks for your time. Okay, goodbye.